Hello dear students, so today we are going to start our integration using trigonometrical identities, right? So you can pause the video to note down the necessary formula which we are going to use in our integration, okay? And one thing I want to remind you is, once you watch this video, you need not refer to your book. Okay, so the practice problems will be given in the description. Fine, so pause the video to note down. So the first problem for the day is given here. So let's see how to integrate this one. Now if I call this to be my A and this to be my B, then what is this? This is sine A, sine B. Yes, and we know that the sine A, sine B can be written as minus half cos A plus B minus cos A minus B. Let's apply this formula out here. So we have, this can be written as, so minus half is there, so minus half can be kept outside the integral sign. So we have cos A plus B. So cos A is mx plus B is nx, right? So cos A plus B is written, so we have got minus, so minus cos A minus B. Okay, so we have got dx, so we'll write dx here. Now, minus half is written outside. So this is cos m plus n x. Yes, x is taken outside as common. So here we have minus into minuses. Plus, so we have got dx as well, so minus into minus is plus half integral of cos m minus n x dx, right? So we know that integral of cos mx with respect to x is given by 1 by m sine mx. Yes, so this is our integral formula. So let's apply this out here. So we have got m to be m plus n. So this m is equals to m plus n out here. So we have minus half into 1 by m. M is m plus n, and the integral of cos is sine mx, right? So similarly plus half into 1 by m minus n. So integral of cos is going to be sine, so it's going to be sine m minus n x. Okay, so we have finished our integration part, so that's why I need to put a constant of integration out here, right? So let us keep this half common. So if I keep half common, then I have, so let us write this plus first. So we have got sine m minus n x by m minus n. So we have got minus here, so minus sine m plus n x by m plus n. Okay, so we have got plus c out here. So this will be our answer. Okay, let's see the next sum. So here we have been given three terms: cos omega, cos 2 omega, and cos 3 omega. Okay, so whenever you have got this kind of situation, it's better to keep the terms in decreasing order of the angle. That is, I will write this to be cos 3 omega, cos 2 omega, cos omega, 2 omega. Okay, so decreasing order of your angles. Now we know that since only cos are there, we will use this formula. So cos A, cos B is equals to half cos A plus B plus cos A minus B. So we'll make use of this formula here. Now let me call this to be A and let me call this to be B. Okay, so if I apply this formula, then I have this half can be kept outside, right? So instead of this, I can write cos A plus B, that is 3 omega plus 2 omega. Okay, we have got plus here, so plus, so cos A minus B, that is 3 omega minus 2 omega. Okay, so this is cos A into cos B formula. So we have got still cos omega left with us. Fine. So let me open the bracket now. Then we have cos 5 omega into cos omega. So cos 5 omega into cos omega d omega. So half into this becomes half. So we have cos omega, 3 omega minus 2 omega is omega. So cos omega into cos omega is cos square omega d omega. Right? Okay. Now we know one more formula, that is cos square x can be written as half into 1 plus cos 2x. Okay, so we'll make use of this formula out here. So again, let me call this to be A and let me call this to be B. Okay, so if I apply the same formula, then I'm going to have half. Okay, so again half is there, so that half can be taken outside as common. So this can be written as cos A plus B, that is A plus B is 5 omega plus omega, which gives me 6 omega. Okay, so plus will be there, but I'll do this part in the very same step. That is the distribution part I am doing in the same step. So we have plus, okay, so 5 omega minus omega is 4 omega, so that's why it will be cos 4 omega d omega out there. So plus 1 by 2. Okay, so this can be written as this much, so it will be half. Okay, so instead of this, if I write this, then I have d omega into 1 is d omega. So we have got plus here, plus integral of cos 2 omega d omega, right here. Now let us simplify this further. So here we have got 1 by 4, here also we have got 1 by 4, so let's take them out as common. So integral of cos is going to be sine. Yes, so as I said earlier, so integral of cos mx dx is going to be 1 by m sine mx. Okay, so here m is 6, so that's why it will be 1 by 6 into sine 6 omega. Similarly here we have got 1 by 4 into, this is sine 4 omega plus, okay, I'm sorry, this 1 by 4 is taken outside, so we'll remove this. So we have got integral of d omega is omega plus, similarly this becomes half into sine 2 omega. Right, so since we have finished the integral part, so we'll put constant of integration out here. So let us simplify this further. So we have 1 by 4 into sine 6 omega by 6 plus sine 4 omega by 4. So let's write this in front. So we have sine 2 omega by 2 plus omega at last with constant of integration. So this will be the answer. So pause the video to note down. Now let us check this problem. So to do the sum, we'll see whether this can be modified or not. Okay, so we have sec theta by cosec theta can be written as, when it goes up, that means if I take the reciprocal of this, it becomes sine theta. Yes, and when we take the reciprocal of sec theta, it becomes cos theta, and we know that sine theta by cos theta can be written as tan theta. Okay, so that means this can be written as tan square 3 theta d theta. Okay, and we know that tan square theta can be written as sec square theta minus 1. Yes, so let me put that formula. So we have, if I put this formula, then I'll get sec square 3 theta d theta minus d theta. Hope you understood this part. Instead of tan 3 theta, I am writing this much. Okay, and outside we have got d theta, so sec square 3 theta into d theta is sec square 3 theta d theta minus 1 into d theta is d theta. Right, now we know that integral of sec square x will be tan x. Okay, and wherever you have got m, it will be mx by m. Right, so I have tan square, tan mx, that is 3 theta by m, that is 3, minus an integral of theta d theta, it will be theta, so with constant of integration. So this will be the answer. So pause the video to note down. Okay, let's have a look at this question. So whenever we have got this kind of stuff given, that means only single term in the denominator and many terms in the numerator, then you have to follow the technique which I am going to follow right now. So what we are going to do here is we'll distribute this sign to each and every term. That means this can be written as cosec x by sin x dx plus tan square x by sin x dx plus the last one, that is sin square x by sin x dx. Now let us simplify this. So the reciprocal of sin is cosec, so when it goes up, so it becomes cosec, and with this cosec it becomes cosec square x dx. Fine. Now let me simplify this further. So this can be written as tan x into tan x. Tan square x can be written as tan x into tan x, right? So instead of 1 tan x, I am writing sin x by cos x. Okay, and we have got in the denominator sin x. Yes. Okay, similarly here this and this gets cancelled, so only sin x is left. So here this and this gets cancelled, so the reciprocal of cos is sec, so this becomes cosec square x dx. Now this goes to the numerator to become sec x tan x dx plus integral of sin x dx. Okay, now what is the integral of cos square x? It is minus cot x. Yes, and integral of sec x tan x is sec x plus an integral of sin is minus cos x, and since we have finished our integral part, so we'll put a constant of integration. So our answer will be sec x minus cot x minus cos x plus c. Okay, so pause the video to note down. Okay, let's see this question now. So again, as I said earlier, if you have got only one term in the denominator, you need to follow the steps which I have followed in the previous sum. Similarly, you can see here that this is only single term, right? So you might say that there are two terms, that is sin square x and cos square x, but whenever you have got a multiplication sign or division sign, that will be counted only one term. Okay, so the terms will be separated by only plus and minus sign. Okay, so let's have a look at this. So as I said earlier, so we will distribute the integrals. So this can be written as dx by x to the power 2, that is x to the power minus 2 dx, and we'll separate this in this format. So we have got sine cube x by sine square x cos square x dx written. Okay, so we have got plus, so we have got cos cube x by sine square x cos square x dx, right? So let us do the integral part here. So here this can be written as x to the power n. So the integral of x to the power n is x to the power n plus 1 by n plus 1, plus here some things are getting cancelled, that is sine square x and this one, right? So we have got sine x, and here we'll take one cos x. Okay, so sine x by cos x becomes tan x, right? And one more cos is left here, and the reciprocal of that cos is going to be sec x. Okay, so we have got dx plus Similarly, this and this gets cancelled. So similarly, we have got cos by sine gives me cot x. Yes, and one sine x is left, and when it goes to the numerator, it becomes cosec x. So we have got this much, right? Now we know that this becomes x to the power minus 1 by minus 1. So integral of sec x tan x is, it is sec x. Yes, and integral of cosec x cot x is minus cosec x. Okay, so since we have finished our integral part, so we'll put a constant of integration, and let us simplify this further. So whichever is positive, I'll write in the front. So sec x is positive, right? So minus cosec x is there. Okay, so now this means minus 1 by x plus constant of integral. So pause the video to note down. Okay, so sixth problem for the day, that is this one. Now, before I proceed, I would like to mention one direct formula which is given in your class 11, that is 1 minus cos 2x by 1 plus cos 2x will be equals to tan square x. Okay, so we can directly make use of this formula. Otherwise, if you don't know the formula, you have already written two formulae, that is sin square x will be equals to half into 1 minus cos 2x, and another one was cos square x equals to half into 1 plus cos 2x. So these were the formula which you already noted down. Now from here we have 1 minus cos 2x equals to 2 sin square x. Yes, so when this 2 goes over there, we have got 2 sin square x. So instead of this, I am going to write 2 sin square x. Fine. So similarly from this, 1 plus cos 2x will be 2 cos square x, and we have got dx here. So this and this gets cancelled. So we have got integral of tan square x dx. Okay, and we know that this tan square x can be written as sec square x minus 1, right? And the integral of sec square x is tan x, and the integral of dx will be x. So since we have finished our integral part, so we'll put a constant of integration. Pause the video to note down. Okay, now let's have a look at this sum. So this particular sum you may come across many times in your class 12 mathematics. Okay, so for example, in your inverse trigonometric functions also you may see this kind of function given to you. Okay, so whenever you see 1 plus sine function, then what you have to do is you have to express this in perfect square. How? We'll see here. So instead of 1 I'm going to write cos square x by 2 plus sine square x by 2, because we know that this is equals to 1. Okay, and this sine x can be written as sine 2 into x by 2, right? So it is like sine 2 theta, and we know that sine 2 theta can be written as 2 sine theta cos theta, right? So I'll make use of these two things out here. So instead of 1 I'm going to write this one, and instead of sine x I'm going to write this one. Okay, so let's see what do we get. So instead of this I'm writing sine square x by 2 plus cos square x by 2 plus, so instead of this sine I'm writing this one, which is 2 sine x by 2 cos x by 2. Fine. So we have got dx outside square root, so dx is written. Now if I call sine to be a, okay, and cos to be b, then it is a square plus b square plus 2ab, and we know that a square plus b square plus 2ab is nothing but a plus b whole square, where a is sine x by 2 and b is cos x by 2. So let us put the formula. So we have square root of, so this full thing can be written as a plus b whole square, and we have dx out here, and we know that square root of this whole square becomes sine x by 2 plus cos x by 2 dx, right? So let's open the bracket. So we have got integral of sine x by 2 dx plus integral of cos x by 2 dx, and we know that integral of cos x is sine x, okay, and whenever there is m, so it will be divided by m, right? Similarly, integral of sine mx dx is going to be minus sine cos mx by m. So let's make use of this formula. Here we have got m to be half. M is half in both the cases, so that's why I'll get, so integral of sine mx will be minus cos mx, yes, by m is half, so again plus is there, so we have got integral of cos mx will be sine mx by m is again half. So we'll put constant of integration, so this can be written as, this 2 goes up, so becomes 2 sine x by 2 minus 2 cos x by 2 plus c. So pause the video to note down. Let's have a look at this particular sum. Here we don't have any quantity in numerator. Now if I take the denominators to the numerator, then I'll get cosec square x for sine square x, and cos square x becomes sec square x, okay? Still we won't be able to proceed further if I do that, okay? So how to do this? Here we have got 1, okay? So instead of 1, we'll put sine square x plus cos square x. Let's see what happens if I put 1 to be this much. Then this can be written as sine square x plus cos square x by sine square x cos square x dx. Okay, so as usual we have got single term in the denominator, so we can split this. So if I split, then I have sine square x by sine square x cos square x dx plus integral of cos square x by sine square x cos square x dx. So as usual these two gets cancelled, so 1 by sine square x can be written as cosec square x dx plus, okay, I'm sorry, here sine square and sine square gets cancelled, so that's why this can be written as 1 by cos square x, which is sec square x, and here we have got 1 by sine square x, which can be written as cosec square x dx. Fine. So the integral of sec square x is tan x, and the integral of cosec square is minus cot x with constant of integration. Pause the video to note down. Let's have a look at 9th problem for the day. So earlier we saw a similar kind of question where instead of cos we had sine. Okay, so our way of solving that was to express this in terms of perfect square. Same thing we are going to do out here, but we'll make use of the formula 1 plus cos 2x equals to 2 cos square x. Okay, so that formula will be used here, and if I use this formula, then this can be written as integral of 2 cos square x by 2 dx. Now this root 2 can be kept outside, so we have got square root of cos square x by 2, which is cos x by 2 dx, right? And we know that the integral of cos is going to be sine, so that's why it will be root 2 sine, it is actually mx, so that's why it will be mx by m. M is half, so my answer will be, when it goes to the numerator, so 2 root 2 sine x by 2 with constant of integration. So pause the video to note down. Okay, now immediately after this we'll have a look at our 10th problem. So we have cos square x minus sine square x. Now obviously this can be written as integral of cos 2x. This is the direct formula, and similarly here I'm going to make use of this formula. So if I use this formula, then I can write this numerator denominator to be 2 cos squared 2x dx. Now again, this root 2 can be taken outside, so it can be written as 1 by root 2. So in the numerator we have got cos 2x. Now square root of cos squared 2x is going to be cos 2x. So we have this 2 gets cancelled, so 1 by root 2 integral dx, right? So this is equals to 1 by root 2 integral of dx is x plus constant of integration, that is x by root 2 plus c will be my answer. So pause the video to note down. So as of now we worked with indefinite integrals. Now we'll take few definite integral sum, and here we are asked to prove the following. So you need to verify the following definite integrals. So this is my question, and the lower limit is given to be 0, upper limit is pi by 4. So let's begin. So let us first find the integral. As I said from the introductory video of definite integrals, I said first you need to evaluate the integrals. Okay, so let me call that integral to be I. Okay, so let me call I to be integral without any limits sine squared x cos squared x dx. Okay, now I am going to do some manipulation out here. So I am going to put 1 by 4, and here I am going to write 4 sine squared x cos squared x dx. Okay, so this can be written as 1 by 4 2 sine x cos x whole square dx. So this is 1 by 4. Now 2 sine x cos x is sine 2x, so that's why this can be written as sine squared 2x dx. Okay, so whenever you get sine squared theta, then what you need to do is you need to put this formula. So we know that sine squared x can be written as half of 1 minus cos 2x, right? So the same formula I am going to use here. So I'll get half 1 minus cos, so whenever it is x it becomes 2x, so here it is already 2x, so that's why I'll get 4x here. Okay, so we have 1 by 2 comes out, so we have 1 by 8. So integral of dx minus integral of cos 4x dx, right? So let's evaluate this. So we have 1 by 8, integral of dx is x, and integral of cos mx is 1 by m sine mx. Okay, and since we are doing definite integral, we are not going to put any constant of integration. Fine. So this is the evaluation of integrals without limit. Okay, so therefore my integral 0 to pi by 4 sine squared x cos squared x dx can be written as, okay, so the integral value is this much, so this 1 by 8 in fact can be written outside. So we have x minus 1 by 4 sine 4x, lower limit is 0, upper limit is pi by 4. Okay, so 1 by 8 is there. So first we'll put the value for upper limit, so it becomes pi by x is pi by 4 minus 1 by 4 sine 4 into x is pi by 4. Fine. Now we'll subtract with the lower limit, that is 0. So value for x is 0. So 0. So minus into this minus becomes plus. Okay. So we have 1 by 4 sine 4 into 0 is 0. Okay. Let's simplify this. So we have this is equals to sine 0 is 0. So that's why this is also 0. 0 for me. Right. Okay, now what is the value of sine pi? This and this gets cancelled, so sine pi is also 0. Okay, so what is left? Pi by 4. Only pi by 4 is left, and pi by 4 into 1 by 8 becomes pi by 32. 2. So that's what we need to verify. So pause the video to note down. Okay, let's see the last problem for the day. Okay, so the question is sec x into square root of this whole chunk is there. So let's try to remove the square root sign from here. Okay, so what am I going to do is I'm going to do rationalization here. So we have left hand side, so I'm not going to write left hand side, you will write by yourself. So you have sec x 0 to pi by 4 into, so within square root sign, let's do some rationalization question part. 1 minus sin x by 1 plus sin x is there. So whenever we rationalize the denominator, so I'll have to put this here, 1 minus sin x. Similarly, I need to put 1 minus sin x here as well, right? So this can be written as integral 0 to pi by 4. Okay, so I'm writing this way because I don't have space, you will write downwards. Okay, so we have sec x into, okay, so 1 minus sin x into 1 minus sin x. So this gives me 1 minus sin x whole square, which turns out to be 1 minus sin x. Okay, square root, because of square root sign, it becomes only 1 minus sin x. So this becomes 1 minus sin square x, which in turn is equals to cos square x, and square root of cos square x is cos x dx. Okay, so we have, okay, so as I said earlier, since there is only one term in the denominator, I'll split this. So after splitting, I'll get 0 to pi by 4. So sec x into 1 by cos x minus sin x by cos x dx. Right? So let us split now. So 0 to pi by 4. Okay, so sec x into 1 by cos x. Again, the reciprocal, 1 by cos x is sec x. So sec x into sec x is sec square x dx minus 0 to pi. So sec x, and this is what? This is tan x. So we have sec x tan x dx. Okay, and we know the integral of sec square x. It is tan x, and the lower limit is 0, upper limit is pi by 4, minus integral of sec x tan x is sec x, lower limit is 0, upper limit is pi by 4. So let us put the values for lower limit and upper limit. So we have tan upper limit pi by 4 minus tan lower limit, that is 0, minus sec pi by 4 minus sec 0. Okay, so we have tan pi by 4, that is tan 45 is, okay, so value of tan pi by 4 is 1 and tan 0 is 0, minus sec 45 degrees root 2 minus sec 0 is again 1. Let us open the bracket. So I have 1 minus 0 is 1, minus root 2, minus into minus is plus 1. So 1 plus 1 gives me 2. So 2 minus root 2 will be my answer, right? Which is my right hand side. So we have successfully verified our answer. So pause the video to note down.